Physics, Chapter 19, Oscillations. So this lesson is it's a bit long lesson. There are many pages describing different aspects of oscillations, but it is not very hard. However, you have to make sure that you learn every part of it and you understand all of it very carefully. And please go through all of it, all the details, and listen to my lectures very carefully. And you will not, if you don't miss anything, and if you follow it properly, it would be really easy for you to understand everything here. The first thing is, so we will come to this engine part after we have learned the basics of this, basics of what oscillations are. Oscillations and vibrations are everywhere, right? A bird in flight flaps its wings up and down, so it's a movement. So that is an example for an oscillation. Now vibration, if you make a sound, and if you keep your hand, if you place your fingers on your throat, if you place your fingers on your throat, you will understand, you will feel that that vibration. If you place your hand on your heart, on your chest, you will feel the vibration, you will feel how it beats. So these are all examples for vibrations and oscillations. Then an aircraft's wings also vibrate up and down, but that is not how it flies. That means it is not exactly how it flies, but it flies because of the thrust made by its engine, and the upthrust made by the movement of its wings, but it does not flap like a bird, right? The wings are long and thin, and they vibrate slightly because they are not perfectly rigid, right? So when you fly, you might see different movements on this wing. It is not very strong, but that doesn't make we are going to crash onto the ocean, right, or onto the land. It is made like that because those vibrations are allowed, right? Those vibrations are part of the structure. Many other structures vibrate. Bridges when traffic flows across, buildings in high winds, so they vibrate. So they are these high-rise buildings. They are they are allowed to. That means they are made in such a way that it would not collapse just because it vibrates. Now, especially in countries like countries prone to earthquakes, they are made in such a way that these allowances are made for them to vibrate. A more specific term than vibration is oscillation, right? So a vibration is actually an oscillation. An object oscillates when it moves back and forth repeatedly. Vibrate means it doesn't go from one place to another, but goes back and forth on either side of some equilibrium position. So there is a resting position. That is what we refer to as equilibrium position. From across that position, back and forth, this vibration will occur. If we stop the object from oscillating, it returns to the equilibrium position. So what it says is, now let's say this is the object. What happens is, this object will, when given a force, it will go here and back here. That means it will come to this position and go to this position, and it happens repeatedly, right? It happens repeatedly. That means back and forth it goes, right? I'm just showing this movement because to show the movement, but it does not actually go in a zigzag manner. It simply goes back and forth like this, right? Moves from left to right. So that, but if we stop the movement, it will come back to the resting position. So that is what it refers to. We make use of oscillations in many different ways. For pleasure, a child on a swing, so that's an oscillation. The swing wood, you would know how a swing works. So if this is the resting position of the swing, right, so if this little fellow will sit here, right, so then it will go to this point and come back to this point. So if the swinging is stopped, it will come back to the resting position, that is this place, right? So that is an oscillation. For music, the vibrations of a guitar string, right? Now, for example, if you are to if someone was to sing a song, let's say a very famous song, My Love. If someone was to sing that song, then that person would have to play the guitar. So when you play the guitar, the strings will vibrate, and you will hear the sound of those strings vibrating, and that sound created will give the music. So we have learnt about notes and antinodes and all of those details, so that is also something that you must try to remember. Then for timing the movement of a pendulum or the vibration of a quartz crystal, right? So in a watch you would have seen that it vibrates. There are vibrations that occur inside the clock, inside the watch. If we stop the object from oscillating, it returns to the equilibrium position. So obviously they they vibrate even if even the watch stops functioning, it will come back to its equilibrium position. Whenever we make a sound, the molecules of the air oscillate, right? So whenever we make a sound, so that means when I'm making a sound, if you were in front of me and if I made a sound, that doesn't mean the air that goes out of my mouth will come to your ear, but rather what happens is the air between us will vibrate. The one layer of air that is right in front of my mouth will vibrate the next layer, and it will come until it reaches your ear, vibrating the next layer. It continues to happen, and in the end it reaches your ear. Passing along the sound energy, the atoms of a solid vibrates more and more as the temperature rises. So you have learned this in detail. When when the temperature increases, the vibrations will also increase, and as a result, the rate at which they vibrate will also increase. These examples of oscillations and vibrations may seem very different from one another. In this chapter, we will look at the characteristics that are shared by all oscillations. So we are looking at the common features of these oscillations, and to try to analyze different factors and do calculations based on the principles they bring about. The first one of the easiest things that we need to learn is whether oscillation is free or forced. The easiest oscillation to understand are free oscillations. If you pluck a guitar string, it continues to vibrate for some time after you have released it, right? So you know what has happened there. So if you pluck a guitar string, what does that mean? It means that if you pluck a guitar string, it will, you after you have plucked it, the sound continues to come because the vibration is continuing. Let's see how it happens. So you see, I have plucked it and it continues to vibrate, it continues to give the music. So after I have plucked it, it continues. The sound comes continuously. So it continues to vibrate for some time after you have released it. It vibrates at a particular frequency, that is, number of vibrations per unit time. This particular detail is known as natural frequency of vibration, right? And it gives the note that we hear. The note is different. So now we can change the, now for example, if we change the length of the string, then the note will change. I'm plucking the same guitar string. I'm changing now this is the shortest length, increasing the length. So I'm changing you can see it is the same guitar string. This is the shortest length, and this is the longest length. You can see a clear difference in the note. So that is, that is how it varies. That is how music is also made. So we can change the frequency, change the natural frequency by changing the length. So this changed natural frequency gave us a different note, right? So if you have seen a tuning fork, right? Tuning fork is, you can Google it, you will be able to see that. A tuning fork has a natural vibration. When you hit an object, when you hit it on something, you can actually see it vibrating, right? Please do a Google search and look at a video how this would work, how a tuning fork would work. Anything that oscillates have a natural frequency of vibration. You can use a meter ruler. You can keep it at different lengths exposed as shown in this diagram. This lady is vibrating it at different. Now this is a long, long piece is exposed or free. So when it vibrates freely, after the initial disturbance, it will gain its natural frequency. Then also some objects can be forced to vibrate, right? So in an engine, there is a vibration. How does it vibrate? This is how it vibrates. There are pistons inside the engine. These pistons move up and down. How do they move? They don't, not like a guitar string. After I have plucked it, it continues to give the sound. But in here, after we have moved once, it does not continue to move. It means that it has to be mechanically adjusted, mechanically moved or oscillated. So that is what you feel when you are in a bus. You can feel that even though the vehicle is not moving, you can feel that vibration. So that vibration is generated at the engine, and that makes the whole bus to vibrate. In the same way, you can force a meter ruler to oscillate by waving it up and down, right? Not like shown in here, but it is waving up and down. That is, you can move it mechanically. However, its natural frequency of vibration will be much greater than this. That is, it will be much faster than you moving it, right? Because as you can see here, it is almost blurry. The movement is blurry. We can't move it in that speed. As you will discover if you hold one end down on the bench and twang the other end, as shown here, right? Please answer question number 1 if you have understood it. But before that, please write down this note. the main topic is chapter 19, oscillations. The subtopic is free and forced oscillations. Under that, write down a vibration is an oscillation when an object moves back and forth, passing back and forth repeatedly, passing an equilibrium position to either side. We say that it oscillates. When it stops oscillating, it returns back to its equilibrium position. Example, child on a swing, pendulum on a clock, etc. Leave a line and write. After a first disturbance, if the object continues to vibrate, we say that it has reached its natural frequency. We say that it has reached its natural frequency. I'm not going to give the definition for frequency. You know that it is the vibrations per unit time. If you have a doubt, please write it down. For example, if a guitar string is plucked, it gives rise to its natural frequency and generates a particular note. This note can be changed by changing the length of the string. These type of vibrations are natural or free vibrations. Oscillation, next point, oscillations made as a result of mechanical movement. Example, vibration or the oscillation of pistons in an engine, or the flapping of wings of a bird are forced vibrations. And this frequency would not be natural frequency, but the forcing frequency. It can be changed by increasing the force on it, by increasing the force applied on it. Right. I hope you understood. Please take a meter ruler and or a guitar and play play or pluck the guitar string, change the length, and see, you would understand how it works. If you have any questions, please raise them. If not, please go move to question number 1, and it is quite easy.